In this video, we're going to look at an example where both the demand curve and the supply curve shift. So in class, we did examples where just the demand curve shifted. We also did an example where just the supply curve shifted. But what about that case or scenario when actually both curves shift? Okay. Again, if you get a problem like this, I'll be very explicit. I won't try to confuse you on which curves shift. Okay. So let's take a look at an example where both curves end up shifting. And our example is going to be our latest hurricane and bottled water, right? So we're going to look at the market for bottled water in Lakeland. We're going to look at it before and after the hurricane hits Lakeland, right? So obviously there's going to be an increased demand for bottled water. We know that's going to be the case. But as we know, roads were blocked, power was out, stores couldn't operate, so the normal supply of water that would typically have flowed to Lakeland couldn't, right? So that's going to indicate there's a decrease in supply. So we're going to have both an increase in demand and a decrease in supply due to the hurricane. So let's draw that up. As usual, we start with our axes here. Make sure we label the horizontal axis with a Q, vertical axis with a P. And go ahead and write down here, this is our market for bottled water. Okay, so let's put in our demand curve. Let's do something like this. Okay, let's label that with a D. Let's go ahead and put a 1 because we know we're going to be shifting it. Okay, and let's go ahead and put in our supply curve. Let's put it somewhere over here, let's say. And we'll call this S1. Okay. And as usual, let's go ahead and put in our equilibrium price and quantity. Okay, so P1 star and Q1 star. Okay. So this is the market for bottled water before the hurricane hits. Okay, everyone's going about their normal lives before the hurricane. Okay. All right, so we know the hurricane hits, so there's an increased demand for bottled water. So let's go ahead and draw our new demand curve in here. It's an increase, so that's going to be a shift to the right. So draw in a demand curve like this. Okay. We're going to label that D2 to show that increase in demand due to the hurricane. Okay. All right, but we also know the supply curve is going to shift. All right. And because roads are cut off because of falling trees, power is out, so stores can't be open. Right? We know there's going to be a decrease in the supply of bottled water. So a decrease is going to be a shift to the left. So let's go ahead and draw in a shift to the left here. Okay. We'll label it S2, and then we'll put an arrow in here indicating the decrease in supply as it shifts to the left. Okay. Now, here's the interesting part, and that is that when we're doing these types of problems, right, we do the analysis and then we look to see, okay, well, what's the new equilibrium price and quantity, okay? Well, it's going to be where our new demand curve and our new supply curve intersect. Okay? So we're going to find D2 and S2, and that's going to be right here, okay? So in this diagram, it looks like the equilibrium price of water is going to rise, and the quantity is going to fall a little bit. So that seems like the straightforward answer. Except it gets a little tricky here, okay? And the issue is, I haven't really told you the magnitudes, and a lot of times you won't know the magnitudes. You just know the supply curve shifts to the left and the demand curve shifts to the right. So let's draw this a little differently. I'm going to erase that. I think. There we go. Let's get rid of that. And we accidentally, well, that's too bad. All right, I accidentally got rid of my demand curve. Did not mean to do that. Let's draw this back in its usual spot here, right around here. Okay, so we got our demand curve back in there. Suppose instead, the supply curve shifts only a little bit to the left. Let me go ahead and get rid of this arrow. Okay. Suppose it shifts to the left, but suppose the shift is only this far, right? Maybe not all the roads are blocked. S2, with the shift going this way, okay? Well, in this example, yeah, the price is higher. Here's our equilibrium. But now it looks like quantity is kind of the same as before, or maybe even a little bit more. So let's do this again, right? Let's get rid of our supply curve, right? What if instead the shift is not quite as big again? So let's draw a supply curve over here. S2, right? It's still a decrease in supply. It's still a shift to the left. But now, our new equilibrium is here. Still a higher price, but now the quantity is even higher, right? So the takeaway here is that when two shifts occur, when both the demand curve and the supply curve shift, you will only know the outcome of one of your variables, either price or quantity. And as you can see in this example, price is always higher than it is before. But quantity could be lower, could be the same, or it could be higher. It depends on the size of the shifts. Okay? So that brings us to this slide, and this reiterates what I just said, right? The outcome is a little tricky when both demand and supply curve shift. We don't know the magnitude of the shifts, so we only know for certain what happens to just one of the variables. And in this case, we know that price, equilibrium price, will increase, but we actually don't know what will happen with equilibrium quantity. We would say it's indeterminate, meaning we cannot determine it. Or you could also just say Q question mark. That is a perfectly acceptable answer on an exam, basically saying you don't know what happens to the quantity. Okay. So if you get a problem that has two curves shifting, take the time, draw it out, and do the shifts in different ways, and you'll be able to find out whether you know for certain what happens to price or what happens to quantity. Okay. And that's it.